the steps that you have up here are about solving quadratics and by factoring and completing the square. So I've listed those steps. They're really hard to follow just by looking at those steps. So write those steps down, but we're going to break down those steps as I go through the problems. So they'll be easier to understand once we actually do the examples. So to solve by factoring, you do want to make sure it's equal to 0 and take out any common factors. Once you have it in that form, remember the rules of factoring. You need two numbers that equal a times c, where those two numbers add up to b. So you need two numbers that equal a times c, where a plus c is equal to b. Completing the square, there are 4 steps. We're going to rearrange to put the x's on one side and the constants on the other. We're going to divide everything through by a if that's necessary. We're going to add b over 2 squared to both sides, and then we're going to factor and solve, but don't forget the plus or minus. That's not going to make much sense until we actually jump to a problem. So I will go over that momentarily. Okay. Yeah. No, that's okay. Okay. So we've got these rules. So let's do the first 4 by solving by factoring. Okay. So remember, it says to get it equal to 0 and then factor. So number 1 is just an example of if you get it to be factored, how easy we can proceed from there. So all that we have to do if we're at this point is to set each individual factor equal to 0. So we get that k is -1 or k is +5. So you know, that's why I was showing you that problem. If it is in that form, how very easy that it is for you to solve. Okay. So, but problem number 2, let's look at the procedures. Now, remember, I said rearrange or take out any greatest common factors. If it's equal to 0, what are the factors of a times c that add up to b? So if we do that, the way that we're going to get -18 is -6 times +3. That's going to add up to -3 in the center. So we know that if we are trying to factor and our back sign is negative, what the middle tells us is where we want the sign on the bigger number. We want the bigger number to be our negative. So that's why we get n-6 and n+3. So you can check it by foiling. -6 times 3 is -18. -6 plus 3 is -3. And then we're going to split it apart. n-6 equals 0. n+3 equals 0. So n is equal to 6 or n is equal to -3. Please get in the habit to realizing that those values are always turning. Those values are always flipping. Okay, so you'll notice that our factor for number 1 said +1, but our 0 or our intercept was -1. Our factor said x -5, but our 0 was +5. And that should happen every time. So what do we notice is different about 3 and 4? It's not equal to 0. So let's go ahead here and add 5 to both sides. So we get x squared minus 11x plus 24 is equal to 0. So we don't factor it until we've gotten to that point. So you always have to relate it to 0. And so the factors of 24 this time the 24 is positive, when that's the case, just look into the middle. That sign will be in both. So the factors of 24 that will add up to negative 11 are negative 8 times negative 3. So you want them both to be negative. So then, but remember, when we go to solve them, they're going to flip signs. So we get x equals 8 or x equals 3. So that shouldn't be anything new. You should have done that back in algebra class. So again, for number 4, you have to subtract 5 from both sides. Then ask yourself, what are the factors of 10 that add up to 7? You know, you only have so many choices for 10. 10 and 1 add up to 11, but 5 times 2 does add up to 7. So that would be plus 5 and plus 2. Now remember, our solutions end up flipping signs. So we get a value of negative 5 or negative 2. Now you can check your work. If you plug them back into the original function, you should always get a correct solution. So if we plug in negative 5, we would get that both sides are equal to 5. If we plug in negative 2, again, we should get both sides as equal to 5. Okay. Now, I would like to, for number 5, I would like to do these with the method completing the square. Okay. So it's a different method. There were 4 steps that you wrote down at the top of your paper, and we're going to go over all 4 steps. Okay. We're going to get the variables to one side. Now I'm going to put a little placeholder. I'm going to put a plus blank. The 38 is going to move to the other side. It's going to change sign. It's going to become a positive 38 plus blank. And then underneath here, you're always going to put the perfect square we're searching for. So that's always what I do for my first step. Unless there's an a value sitting on my p squared, I move the variables to one side, constants to the other, plus blank, okay, it's a little placeholder. So you're always going to look at your variable. That's going to come down. What's going to come down here is always the same thing, okay? We are always going to divide our coefficient, the b value. It's always b divided by 2. Your b in this case was positive 14. Divide that by 2. Get not that. Get 7. Half of 14, last I checked, Mrs. Hot, was 7. And then this is always that value squared. So then just square it. And so if we square 7, 7 squared fills that spot. And whatever you add to one side of an equation, you add to the other side. So that's why it's going to be 49 that goes into, especially we need it for that numerical side to show. And 38 plus 49 is 87. Yeah. And so now the next step said that you can solve it, but don't forget your plus or minus. So the thing that's going to get rid of our square is a square root, but put that plus or minus on the numerical side. So we get at this point that our quantity p plus 7 is plus or minus the square root of 87. Now 87 is 3 times 29. Both of those numbers are not perfect squares that can help us. So just leave it alone. And then tuck the 7 in front of the plus or minus symbol. Change its sign when it goes over, because we're going to subtract 7 from both sides. And so we get negative 7 plus or minus the square root of 87. Now this technique gives us the exact same stuff we would get if we did the quadratic formula. We would get negative 7 plus or minus the square root of 87. It allows us to do it without plugging it into the quadratic formula. The quadratic formula was derived by this method. That's where that plus or minus comes from. But this is completing the square. It's a pretty time-consuming process. Okay. If I were asked to do this, I would probably just use the quadratic formula. I usually go, is it factorable? Yeah, I'm going to factor it. If it's not, use the quadratic formula. Otherwise, you're stuck doing this process. But let's do it again. There's no front coefficient on our v squared, so that's great. We're going to put our v's to one side, plus a blank. Numbers, change sign, plus a blank. We're going to set up our little perfect square underneath to hold our information. Our front or our b value is 6. We're just going to take 6 divided by 2. That's going to go in that spot. So it's always this b value divided by 2. So in this case, 3. And then 3 squared fills this spot. And I usually will put maybe the number on the one side. Oh, I got to square 3. And then actually do it for the other side. And I get 68. And so I get that v plus 3 is plus or minus the square root of 68. Now let's analyze for a moment the square root of 68. 68 is 4 times 17. Since 4 is a perfect square, so let's rewrite that in its simplified form. We get v plus 3 is plus or minus 2 radical 17. We're done only when we tuck this in front of the plus or minus. If it's a positive 3 on the left, it's a negative 3 on the right. Okay. Again, if you were to use the quadratic formula, you would get that same exact value. Okay, so that's completing the square. We're going to do 2 more just to make sure we're getting the hang of it. So again, numbers and variables need to split up. Put your variables on one side, change the sign of your number, put it on the other side. A blank is going to be there to remind us what to do. Half of the b value of 14 is 7, and it's positive. So that's going to be a plus 7. So 7 squared fills my spot, or 49. So now this is a nice one, because when we square root both sides, we get plus or minus the square root of 100. Because we get a perfect square, we can just take that square. So that's a plus or minus 10. When that happens, when you get that perfect square, that means the original version was factorable. You just didn't see that, or, you know, that wasn't the method they wanted. So when you get this negative 7 plus or minus 10, those are numbers we can actually do. So let's actually do it. So negative 7 plus 10 is positive 3. Negative 7 minus 10 is negative 17. So it is factorable. We could have factored it from the start. It would have factored to be a minus 3 times the quantity of a plus 17. Now, 8 requires a few more steps than the ones we've seen so far. We're going to put the variables to one side, plus a blank, equals the number on the other side. The only one that was in the wrong spot was the 8a. It moves to the other side and becomes a negative 8a. Now we can't proceed with the method until the a squared coefficient is 1. So we have to divide everything in the equation by 2. Even if it wouldn't be divisible by 2, we would have to use fractions for this method to work. But they were lucky, and we're lucky, they're nice to us. Let's divide everything by 2. We get 8 squared, a squared, minus 4a plus blank equals negative 3 plus blank. Now we proceed with the next step. We're going to put our little square. We're going to take half of our b value. Half of negative 4 is negative 2. Negative 2 squared is going to fill my spot. Negative 2 squared, you can do that in your head. Negative 2 times negative 2 is positive 4 or 1. This is also a factorable quantity. We can take the square root of 1. The square root of 1 is just 1. So we get a minus 2 is equal to plus or minus 1. Now, a minus 2 plus 1 and a minus 2 minus 1 we can solve for a if we just add that 2 and put it in front of the plus or minus symbol. So you'll notice it became a positive 2 when it sat in front of there. 2 plus 1 is a value of 3. 2 minus 1 is a value of 1. So that is how that one works. Okay. Now I need to add 2 things for us before we move on. There are some try these down at the bottom. So I want you to try some of yourself before you turn this in. So that's your homework. But before we do that, I want to put into Vertex form. So I'm going to add a 9 and a 10. So we're going to use this one. F of x equals x squared plus 14x minus 38. And f of x equals x squared plus 14x minus 51. Okay. So we're going to do 2 problems that says to put into Vertex form 9 and 10. And then I have Vertex form showing right here, so we have it as a reference, okay? Now, here's why Vertex form is so important. If we can't find the vertex, we can't graph it. And if we can put it into Vertex form, the graphing process goes so much quicker. And we're going to explore that more and more as we go through the process in Chapter 5 as we talk about other types of polynomials and power functions. Okay, so it's almost the same technique. I'm going to do 9 by completing the square. I'm going to do 10 in a little cheat method. Okay, let's do 9 the official way. Okay, so this is an expression. It is not an equation. So if we add something to the expression, we have to also immediately subtract it off. So we have to add and subtract. You remember how before we had a block where we added on both sides? So we're going to do the same thing, but I'm going to put in parentheses x squared plus 14x plus blank. And then I'm going to put minus 38 minus blank. Only because this is not an equation, this is an expression. We're still going to do the same thing. Half of 14 is 7. But I technically need a 49 here to make that work. I can't just add something to an expression without subtracting it off immediately to balance it out. So I have to subtract it off, and I get minus 87. The vertex of this parabola is -7, -87. This one always changes sign. This one does not. This one always changes sign. This one does not. Okay. You might recall, if you look right at problem 5, look what we got. The 7, the 7, the 87, the 87. Those numbers do appear in the completing the square method if it's an equation. Now, 10 kind of corresponds with number 7. I'm going to show you a little shortcut method that you might like a little better. Either method works, you decide. Would you agree my A value is 1? Right? Okay. Let's talk about H. Yesterday I told you that the vertex can always be found by -b over 2a. So that's -17 divided by 2, or -7. Ooh, what did we find earlier? Our vertex's x was -7. If I plug in -7, guess what I get out? I get out, oh my gosh, -87. So I know my vertex is -7, -87. So now I can complete the square just by using this formula. The A value is 1. I'm going to write it just for visual sake. If it's a 1, you don't have to write it. X minus -7, that's why it's plus 7 squared, plus a -87, I can just write as minus 87. I get, oh, I'm sorry. I've totally made up that it is not, this one's 51. It's not 87. I was hoping it was 87. Oop, oop. We did it earlier. Okay, wait, when we plug in -7, I'm just going to have to plug in -7, guys. Wait a second. I was looking at the other equation. Okay, plug in -7. We get 49 minus 7 times 14 minus 51. Oh, that's the -100 one. I'm so sorry. So our vertex is -7, -100. So that's, see over here, -7, 100. Sorry about that. Okay. So now we got the correct vertex. So just plug everything in. It's 1 times x plus 7 squared minus 100. I was thinking I did the same equation twice. Okay. So you can just find the A and the H and the K without doing the completing the square method. The completing the square method does work too. It does it for you as you know, so you decide. Okay. So now, please do the problems down at the bottom. I think I've posted that this is due Friday, but as long as you get it to me by Sunday, I'll, like all your homework, you'll get full credit. Okay, so now could we all go into iMath? And could we please look at today's pre-class M54 day 2. It's the only thing on today's calendar. Let's open it up and let's do it together, okay? So I am going to give you just a second here. I'm going to give you, we're going to walk it through and talk about what they're looking for, okay? Okay. So it says, your classmate claimed that the vertex of the quadratic was 5, 4. Let's investigate the claim. So remember, our vertex forms looks like this. So the fact that the vertex is 5, 4 is a legitimate claim. But let's talk about how we can really test that. Well, if we test in a number like -5, let's think you think it's -5. If you plug in -5, you get 3 times 100 plus 4, or 304. So g of 5 is only 4. G of negative 5 has the larger output. So the larger output occurs when x equals negative 5. Does this disprove what your classmate said earlier? Well, no. We want to get a value higher than that, because remember, our vertex for a parabola that is pointing upward should be the smallest or the minimum. If it's a parabola pointing downward, if our a is negative, it should be pointing upward. So that's good. Does this disprove something your classmate said earlier? No. Why is this? Well, that's because g of negative 5 is higher than what the vertex was, or what he thought the vertex would be. This would be an example that when x is bigger or less than 5, that g of negative 5 should be bigger than 4. This answer does provide evidence of your classmate's argument. So that's what they're looking for this first little section here, okay? So that's what they were looking at. They're just kind of showing you, hey, it has to be the littlest value, and that's what happened. Now let's go to question 2. Question 2 says, we've got a function. I would suggest maybe writing it down on a sheet of paper when you get to the homework, okay? So we know that the vertex happens at 3, 8. Remember, this one changes sign, this one does not. Our a value is negative, so we know it looks like this. So our vertex is a maximum. So if we just look at that equation, pull that information out before we do anything else, it will make then the question flow a little nicer. So it says, try to use some reasoning your classmate used to show that a certain point is the vertex. So when x is equal to 3, because that's our vertex is x, then that x minus 3 becomes 0. Even if we multiply by negative 2, still going to get 0. But f of 3, so this part is 0 when we plug in 3, but you still have to add that 8. That 8 rows that vertex up. So f of 3 is going to equal 8. This implies that our vertex is 3, 8. Okay, so that's just talking about what the vertex is. Now, when x is bigger than 3, so I pick a number like 4. So that thing would be greater than 0. But if we multiply an inequality by a negative, now it's going to become less than 0. So f of x would, the height would be less than 8. That's all they're saying there. Okay, let's talk about that again. When x is bigger than 3, so we have to be over here on going down. X minus 3 squared would be bigger than 0. So if I multiply by negative 2, it's going to be less than 0. So the function has to be below 8. Okay. If our x is bigger than 3, it initially would have been bigger than 0. But when we multiply by a negative, it becomes less than 0. So our function value still would, on the other side, would be less than 8. These statements mean that our vertex is on top. It's a maximum. So that's what they wanted for all of that. Okay. So they're just comparing the vertex. So you always want to write down your equation. Look at what the vertex is. If your a value is negative, your parabola is upside down. Your vertex is a maximum. If your vertex, or if your a is positive, your vertex is a minimum, because then it would look like that. So that's all they want you to know and what you to do for this pre-class. Okay, Now, we don't have a lot of time, but let's just look at the first few questions on the homework. So if you could open up 5-4 homework day 1. That's due on Sunday. 5-4 homework day 1. Okay. So question 1 says to solve each of the equations. See how they have no way of knowing how. Okay. So for A, I always check is it factorable. I can't make that determination until I get it equal to 0. So let's subtract 2x and let's subtract 8 from both sides. We get x squared plus 6x plus 9 equals 0. So that is a factorable thing. So that's what you should always check. If it's not factorable, jump into the quadratic formula. So that factors to be x plus 3 and x plus 3. They both give us a value of negative 3. Okay. Now, the part B asks us to solve that one. See how they say first solve by getting equal to 0. So I'm assuming they want us to factor it. So I'm going to subtract 3x and subtract 26 from both sides. And that factors to be x minus 6 and x plus 2. I think in the past they've had us, if there's multiple answers, to separate them by a comma. So let's do that. So we get x equals 6 or x equals negative 2. So I'm going to put in negative 2 comma 6. So that's what I believe you're doing for the first few questions. So let's try, if there's one that's not factorable, you have to use a quadratic formula. It seems like a lot of these are like that. So let's jump to question 8. Okay, let's jump to question 8 and do that together. And then we'll look at day 2's homework, okay? So question number 8 says we've got this function. I would definitely have a sheet of paper down so that you can work out the work on your sheet of paper, or Notability sheet of paper is fine. It says, where is the function equal to 0? If it is a factorable quantity, you're going to use the factored form. It is not a factorable quantity, just trust me on that. You can't factor. You can try everything you want. You're never going to get that 13 in the center. So we're going to do the quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c is negative 4 times 2 times 3 is negative 24, all over 2a's, which is 4. Now, 169 minus 24 is 145. There's not much I can do to that. I'm going to see if iMath will accept it, but here's what I want you to do. Put that entire top in to parentheses. I think you can type a plus, then a minus. See how it makes the plus or minus symbol? And then squirt for square root of 145. I don't know if it's going to accept the plus or minus. So you see how I have the entire parentheses around the top. Then I hit divided by 4. And always check, is the preview what you wrote on the paper. Okay. So see how it only gave me one answer? I'm thinking it might not like it. Yeah. Okay. So I'm going to take out the plus or minus, and I'm actually going to separate it by commas and type it in twice. One with a plus and one with a minus. Now, I don't know if they're going to want me to do anything else, but you see I have two answers. Let's see if they like that. Now, I did the quadratic pretty quick, so hopefully, yeah, see, it's right. Okay. Now, what are the roots? The roots are where the function equals 0. So I am going to copy and paste that right back into where we see. Okay. What x values produces a maximum? Oh, that's our vertex. The first one there is our vertex is x. So it's just negative b over 2a. So negative 13 over 4. I'm not going to do that. And then what is the maximum value of the function? I got to plug it in. I'm not going to plug it in. Well, I am. But I'm going to let iMath do it for me. It's 2 times that thing squared plus 13 times that thing plus 3. So I am going to see if they'll just allow me to plug it in and they can do the math for me. Yeah, see how they did it for me? So I got the value in C. I then just plugged it into the formula and let them do the actual plug-in. You can actually do it, hit preview, and if they want a number, the number will be sitting there. Okay. Now go to, please, to homework. If the bell rings, I'm going to just talk to myself. So you're welcome to stick around if you want. Go to homework day 2. I'm going to do at least one of these. So here is the one where they have done the thing where they're starting the process. See, the little blank is exactly like my little blank, which is great. Okay. Half of negative 2 is negative 1. That squared has to fill that. You could probably just put in negative 1 in parentheses squared and they would give it to you, but I'm just going to put 1. I know that's 1. Oh, this one I have to do a minus 1. Sorry. Okay. Let's see what question 2. Question 2 is the same. Question 3 is the same. Question 4 is the same. Question 5. Oh, question 4 is not the same. Okay, I'm going to do question 4 with you guys. So it's almost the same. And I didn't do one like this because I just didn't even think that they would. Okay, anyway. So we would fill this spot with half of 8 is 4. 4 squared fills the spot. So that's 16. Okay. But technically, negative 3 is in front. So negative 3 times 16 is negative 48. I have to add the opposite over here. So I actually have to add positive 48. I have to counteract whatever I did to mess up the equation. So that would be a 16. Wait. That would be a 48. So that's like that. And then let's do question number 8. It says complete the square to put it into vertex form. So I'm going to divide off the negative 1. I'm going to get x squared minus 6x minus 11. Okay, so that's our initial step. We're going to do half of negative 6, which is negative 3 squared is 9. But there's a negative there. So negative 9, the opposite of that is to add 9. So the vertex form is negative x minus 3 squared minus 2. So that would be the opposite of x minus 3 squared minus 2. So our vertex is positive 3 comma -2. If they let me submit. So there you go. If you get stuck on anything, just let me know. But there are a few of the homework questions for you, okay?